Hello and welcome to the Daily Space for today, February 15th, 2019. I'm your host, Dr. Pamela Gay, and I am here to put science in your brains. Today we have stories that are strangely brought to you by the letters C and M. This is one of those fascinating coincidences where sometimes you look at a thing and you're like, okay, I'm going to roll with it because this is what the universe gave me. So literally, our stories are focused on the letters C and M. Follow along with me if you will, and I'm hoping you will because this is where I'm going. So as a starting point, we have a story of the Chang'e lander on the moon that was landed there by China. And the IAU has now officially recognized the names that China has given to the Chang'e landing site. Now, the original reason that I was drawn to this story has nothing to do with the letters C or M, but rather with the fact that that lander hasn't been there all that long, and already the names for its region are completely official. This is because China filled out the paperwork, which sometimes is all you really need to do is follow the paperwork and follow the rules, and things become official. Now, you may know that the names given to many of the regions on Pluto, on Charon, on other objects observed by New Horizons are not at all official. This comes down primarily to, did they or did they not read the rules, follow the rules, submit the paperwork? So I would encourage all of you out there who want to see your names made official, and I, as currently a journalist, want to see your names made official because it's easier for me to use them. So please submit your paperwork and make your names official. Okay, so to tell you what we know about the names that China has chosen for this fabulous region where Chang'e has landed. According to the press release coming out of the International Astronomical Union, the IAU Working Group for Planetary System Nomenclature has approved the name Satya Tanhi for the landing site where the Chinese spacecraft Chang'e 4 touched down on the 3rd of January this year, in the first ever landing on the far side of the moon. The name Chang'e originates from the ancient Chinese name for the Milky Way, which was the sky river that separated Nulong and Xinyu in the folktale The Cowhead and the Weaver Girl. The Cowherd and the Weaver Girl. 4 other names for features near the landing site have also been approved. In keeping with the theme of the above-mentioned folktale, 3 small craters that form a triangle around the landing site have been named Xinyu, Haegyu, and Tianjin, which correspond to characters in the tale. There are also names of ancient Chinese constellations from the time of the Han Dynasty. The 5th approved name is Mons Tai, assigned to the central peak of the crater Von Karman, in which the landing occurred. Mons Tai is named for Mount Tai, a mountain in Shandong, China, and is about 46 kilometers to the northwest of the Chang'e 4 landing site. So the way names get made official is really, you read the rules, you fill out the paperwork, then you submit the paperwork to the International Astronomical Union's working group for naming and naming for planetary system nomenclature, and the things get made official if they all match up correctly. So do the thing, people, do the thing. Now, for full disclosure, I am an officer of the International Astronomical Union's Division C. This is the Education, Public Outreach, and History of Astronomy Commission, Commission C, and I am part of Division C2, which is the Division for Public Outreach and Communications of Science. I have nothing to do with the naming of things, however. So that is the story of, a Chang'e moon crater getting named. So in our next story, we have Chandra looking for missing mass in our solar system. The way that we get at the ratio of the different kinds of mass and energy in our universe is in general multifaceted. We look at how things are expanding. We look at how things are accelerating as they expand. We look at the amount of energy seen in things like the cosmic microwave background. And when we put all these different observational pieces together, we get at a very specific ratio for the amount of regular matter. So hydrogen, helium, lithium, beryllium, boron, carbon, all the normal atoms. The unstable stuff like muons and tau particles, all the things that are described by the standard model of particle physics. That is our normal matter. Now, beyond that normal matter, we also have dark matter. This is material of some sort that does not work or play well with the electromagnetic force. It does not bend, well, it does bend light gravitationally. It does not reflect light. It does not emit light. It is having nothing to do with light as near as we can tell, which means that the only way we can detect it is through its gravitational interactions with other matter throughout the universe, which is fine. We can see how things gravitationally interact. And then the third kind of stuff that makes up our universe is dark energy, and nobody knows hardly anything about our dark energy. We know its magnitude. That's about it. It's about 1 proton's worth of mass energy per cubic meter of universe in the present day. Now, the thing is, from all of these different observations, I can tell you how much regular mass there should be, but I can't point it all out. It turns out that a significant chunk of the everyday matter in our universe does not want to be found. And we've had ideas. Some of it we know is tied up in planets that are hard to find. Some of it is tied up in cold, dark gas, which is hard to find. Some of it is black holes, which are just sitting there being black and scowling and emo because no one sees them. All this invisible stuff is out there hiding matter. So the trick is, how do we make the invisible visible so that we can get a full inventory of the regular matter in our universe? With things like random planets, black holes, things like that, we've had the Matcha project, which has been looking for gravitational lensing. We've been measuring cosmic reddening to get at what is the dust within our own Milky Way. And with Chandra, scientists have finally tuned in on a way to find this missing matter by looking at how maybe it absorbs X-rays. So what they've been doing is there was this idea that after the Big Bang, some of the warm and hot gas in the interstellar medium, in the intergalactic medium, so this is called WIM, warm, hot, intergalactic medium. It was suggested that some of this stuff, which isn't giving off enough light that we can see it, but isn't so cold that it's blocking light from stuff behind it consistently, the idea was that this material may have collapsed in to the large-scale structure of our universe, forming giant filaments that have the potential to absorb out X-ray light from background galaxies. Using the Chandra X-ray Observatory, which orbits our own planet Earth, scientists went looking for this gas that is somewhere under 100,000 degrees Kelvin, and that's the warm component. And they went looking for the hot component, which is over 100,000 degrees Kelvin, and in looking for it in the light of background quasars, which give off X-rays, scientists were able to find 17 different filaments of this warm, hot intergalactic medium at a variety of different distances from the planet Earth. So it turns out that in the intergalactic structure, which I show up here in a computer simulation, there is the ability to look for places where there are absorption lines in the background X-ray luminosity of background objects, in this case a quasar. And those absorption lines correspond to places where these filaments through our universe are absorbing out X-ray light and where the hidden mass is lurking. So Chandra has found a way to make the invisible visible by looking at how it's making other things less visible. So it's invisibility all the way down, whatever you want to call it. It's kind of amazing to know that we are still finding new ways to find missing matter. These are the things that you don't realize are going to be so hard. Looking out and just seeing all the stuff that's out there, it's supposed to be just a matter of setting up a telescope and looking. But the universe likes to make things as difficult as possible. But Chandra solved one small problem. Now, in other news, I don't know if any of you have seen this image, but when I saw it, it just kind of was like, oh, wow, that's not CGI. This is a still taken from a video that was obtained by a woman on a cruise ship that was getting ready to leave Cuba. In this particular case, this is video that was taken by Rachel Cook. And it is of a meteor that came in and broke up over Cuba a few months ago. Now, what is awesome about this particular Cuban meteor crisis is it was a meteor that basically came in from the direction of the sun, was completely unforeseen, completely unprotected, and just like the Chelyabinsk meteor, after the fact, scientists were able to recreate the essential orbital insertion, or atmospheric insertion rather, of this object from security videos, random phone videos, and in one case, the tourist video of someone on a cruise ship. She was taking this video as the boat departed Cuba just to document her cruise. I've done the same thing. It's strangely pleasing. But in this case, she caught an image that looks like it's a still from every sci-fi movie of a meteor attacking Earth that has ever been made, but this is real. So scientists from Colombia pillaged YouTube for as many different videos as they could find. And this is the same team that did this work for Chelyabinsk. And just like they did with Chelyabinsk, they were able to recreate the path. Now, in this case, this is the island of Cuba, and you can see a line coming in and heading down, and this represents the incoming path of this meteor. So you never know what your video is going to be good for. And it just might be that if you see a flash in the sky, that flash is a shrapnel of rock coming in from the universe as it wages war on our planet. And we can figure out exactly where the universe is firing from, just from random videos posted on YouTube. You never know where your science data is going to come from. And I just love this particular example. Let's look at Robin Cook's picture one more time. How amazing is this? So those are today's top stories. I do want to remind you that if you want to get out and look up at the skies, take your own photos and videos with me and many others, Fraser Cain, Skylius, Paul Matt Sutter, John Michael Gaudier, we are all going to be at Joshua Tree on June 26th through the 30th, 2019, provided at least 30 people sign up to join us. So go to astrotours.co and check it all out and join us, please. And Joshua Tree right now is a particularly soft spot for me. This is an amazing national park that has trees that are thought to be thousands of years old, or at least 1,000 years old. And These trees are likely the last generation that will live there of this particular kind. As our climate changes, as the environment where different kinds of bugs are able to exist, these trees are losing their pollinators. And they're also losing the exacting requirements that they have to grow. So while they're still standing, let's go hug a tree, or at least visit a tree and take a picture of it, and take a picture of the sky and share a night out under the stars. Now, if June and Joshua Tree just isn't something that's going to do it for you, that's okay. That's okay. We have other options. Here, I would encourage you to join me as we tour through the American Southwest, starting in Tucson, Arizona, where I work for the Planetary Science Institute. I actually live in Southern Illinois, but we're going to be starting in Tucson, which is also where Kitt Peak National Observatory is. All the amazing telescopes. This is the place where I did some of my earliest science, where I spent a summer getting to observe things like Shoemaker-Levy 9 up at Kitt Peak. And from there, we're going to take off through the desert Southwest, ending our journey after going through the Canyonlands with a trip to Las Vegas, baby. So if you want to hear stories of my scientific upbringing as we explore what I consider to be some of the most beautiful country in the world, join me in late August out in the American Southwest, also part of AstroTours. So check out astrotours.co/starstrider, and I hope to see you on a desert night. So that concludes today's episode of The Daily Space, but I'm now going to hang around and answer your questions. All I ask is you type them in with @CosmoQuestX so that I can find your questions in the chat. While you get those typed in, I want to remind you that Daily Space is part of CosmoQuest. We are your place to learn and do science. We bring you the Daily Space most Mondays through Fridays at 1 p.m. Eastern, 10 a.m. Pacific. That is 6 p.m. Greenwich Mean Time. Now, if you can't catch us live, that's okay. All of our episodes get uploaded and stored on YouTube as quickly as the upload-download demons allow. Check us out. And, even if you are watching us live on Twitch, we'd really appreciate it if you subscribe to us on YouTube. It really helps the visibility of our videos. So thank you all so much for being here, and consider giving us a follow to find out when we go live. We don't just bring you the Daily Space, we also bring you launches, landings, special events. Annie hosts Sunday Science Hour every Sunday at the same time as the Daily Space. We are here because of you. We are sustained through your subscriptions, and every bit really matters. Thank you so much for making the donations that make it possible for us to put the science in your brain. So I'm now going to look and see just what questions you have to ask. Thank you, Ed Thompson. Thank you for your robotic bits. I like the emote you chose. Thank you. Can we light up the chat? And thanks for that. Okay. Flipping through all the windows. Too many windows. This is a common problem for me. I will answer your questions as soon as I can get my screen reorganized. Okay, so here we go. Scrolling back. Oh, there was a tier 1 sub that I missed. Thank you, K Barut. Thank you so much for being here for 3 months as a subscriber. Let's see what else in here I might have missed. Scrolling. Hanny's Warverb, I did not mention neutrinos. Why do you ask? Neutrinos are a thing. They're an important thing. Neutrinos are regular baryonic matter, if that's what you're asking. So Henny's Vorwerp is asking, can stars form in this medium eventually, referring to the warm-hot intergalactic medium? I don't know. The issue is, as long as they're warm or hot, the gas is moving around too fast, colliding too much for it to collapse down into clouds that are dense enough to keep collapsing to form stars. You really need cold molecular clouds to have star formation rather than warm, hot gas. The other issue is I just don't know if they have the densities or the potential to have the densities over time. It could be that given the fullness of time, they will condense down enough, but I don't know what the interplay between them getting stretched out by the expansion of the universe versus cool off times is going to be. So it could be that the gas just gets spread out too far before it cools off enough to form stars. It's a really good question. I can tell you the factors that go into answering it, but I can't tell you the answer. I suspect the answer is no, but I don't know for certain. Okay, let's see what else is in here. Yeah, I totally had a Freudian slip on Cuban Missile Crisis instead of Cuban Meteor Crisis, which is what I really meant to say because it was a good turn of phrase, but I screwed it up. Okay. Let's see what else is in here. The Raven Lillian asks, so what did they name the area that the Chinese rover is in? So where it landed is a already named crater. It is the crater von Kármán. And that particular crater had already been named using global maps of the moon, where they name all the significant objects. So it landed in a fairly significant crater. It is now naming the small stuff that is around it. I will drop in a link to the press release so that you can read more and click through the links to read the stories related to all of these names. Let's see. So Disillusioned asks, Dr. Richards used to stream stuff daily. Is he still around? Yes, he's currently, we had massive funding issues with CosmoQuest, which many of you helped us solve to a point. But we didn't bring in enough money to keep our entire team together. And Dr. Matt Richards is currently working with a survey team doing other studies of rocky surfaces throughout our solar system. He is still employed. He's not unemployed. He's just not employed by us right now. So here's to hoping that things go well. So far they are. It just means that since he's not part of CosmoQuest and he is working on new projects that fund him to do specific things, he's just not around. We miss him. He was a good guy. So, okay, continuing on. So Henny is asking, how dangerous is it from an astronaut perspective to just be outside on the moon? So you don't worry too much about getting conked. Micrometeors are always an issue, but the size of a human and the frequency of the micrometeorites generally mean that the probability of any given astronaut getting hit by something that's dangerous is pretty low. The real worry is radiation. Specifically, you have to worry about a coronal mass ejection while you're on the moon that cooks you in place with high energy particles that do bad things to your DNA. We've been extraordinarily lucky so far. The Apollo astronauts managed to be there in between solar flares. They were there when the sun in general was pretty quiet. We need to solve the radiation problem, and we just haven't figured it out yet. So let's see. So Henny asked, how long did it take for the gas at the beginning of time to cool for star formation? I think it depends on which gas. So star formation is an ongoing process. The very first stars, we believe, began to form just a few million years after the Big Bang. So I guess the answer is a few million years. To get you a more definitive answer, we really need the James Webb Space Telescope or something similar, or really anything that can look in high resolution at very faint objects in the infrared. The light from those first stars forming has all been redshifted out of what we can see with telescopes here on the surface of the planet. So we need a cool and awesome infrared observatory. May somebody please launch one sooner rather than later. So Dr. Plazas will come back. So Dr. Plazas is going to be doing some volunteer work with us. He's currently getting geared up with a new project. I don't know if he's talked about it publicly, so I'm not going to say what it is. I'm super proud of what he found for him to do. He is going to be a rock star. He is one career level ahead of Dr. Matt. Dr. Matt will get there as well. So yeah, life is good. So Henny is asking, could the square kilometer array help in finding an answer? Not so much. It's looking at different things. It is, for those of you who don't know, the square kilometer array is a set of radio dishes being built in the outback of Australia and being built in the southern part of the continent of Africa, spanning multiple nations and led out of South Africa. These two different arrays of telescopes are working in two different parts of the radio spectrum, and together will allow us to go deeper into the sky, seeing new and possibly amazing details than we're currently able to see. This is a follow-on in some scientific ways to Very Large Array, helping us to flesh out the spectrums of light that we're able to make detailed observations in. ALMA gets us the millimeter, and the Square Kilometer Array will get us longer wavelengths. So between the Very Large telescopes down in Chelyabinsk, the Atacama Millimeter Array, and the upcoming Square Kilometer Array, we're looking pretty darn good at what we're able to accomplish from visual down. It's the shorter wavelengths and then that pocket of infrared which we can't see from the surface of our planet. These are the places where we still need more help, and that's, again, all those wavelengths are things we can't see from the surface of the planet, which just makes it so much harder to construct telescopes. So that's where we're at. And I think I'm going to end today's show here. This is not to say that science is ending for today. Later on, in an hour and a half over at YouTube, Astronomy Cast is going to be broadcasting live our latest episode. Today's episode is going to be stories of those times when the universe did things that made various people think that someone was about to start World War III. We've all heard the story of gamma ray bursts, but what other things are out there that have almost led to keys going into the locks and rockets getting launched? So tune in. I will be there with my fabulous co-host, Fraser Kane of Universe Today, and we will take you on a facts-based journey, not only telling you what we know, but how we know it about this universe we all share. So thank you all once again for being here today, and thank you for bringing the brains. Thank you for the bits, Trucker Kev. Can we light up the chat with rockets to celebrate the bits? Thank you so very much. Thank you all for being here. Thank you for supporting us, for bringing the questions, and bringing, well, your willingness to learn. As I said earlier, and as I'm going to say again, the Daily Space is part of CosmoQuest. Give us a follow here at CosmoQuest X on Twitch and find out when we go live, bringing you launches, landings, special events, and the Daily Space and Sunday Science Hour, all at 1 p.m. Eastern, 10 a.m. Pacific. That is 6 p.m. London time. We are part of CosmoQuest, your place to learn and do science. And we are all produced out of the Planetary Science Institute, working in collaboration with Youngstown State University. We are supported by you. Your subscriptions sustain us, and every bit really helps. And we are so very grateful for all that you've done to make this show possible. I'm now going to run the credits, and when I'm done with those credits, I'm going to find someone to raid. So wherever you are in the world, have a fabulous morning, evening, or afternoon, and get outside and look up.